All right, what is a photon? So an actual tiny bit of photon is one little discharge from an electron. It is sending out angular spin. And I know people are freaking out. Right? What are you talking about? It's angular spin. If a electron is spinning too fast, its own little, like a top, if it's spinning too fast, it has to release that spin, and it does so as a photon. And that photon looks like light to us, and it travels at the speed of light. Just like Maxwell says, it spins at the speed, spinning this way, spinning this way. You can even spin this way. This way gets important. But when it spins this way, it creates positive, negative, positive, negative. Magnetic field, electric, magnetic. Just think of it as positive, negative. And when it hits another electron, it carries that spin. And it transfers that spin over to the other electron. And this is how an electron gets rid of any excess spin. If it gets too much spin, it goes to the wrong energy level in an atom, and then it has to release that spin. And everybody's bugging out that doesn't understand this. That's all right. So, when we do the laser tests for quantum entanglement, we're doing lasers. It's not a single photon. They lie to you about that. So a single photon entanglement test, what they're doing is they're doing a laser that's been dimmed down to a tiny, 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 tiny little laser. And that thing goes straight as heck, and it goes into this crystal that's shaped like an X. Like a lot of crystals, they're all like the same way. So they'll let it come in and diffract and follow that. But they got certain crystals that come in shaped like an X. So the laser comes in, they keep shooting it until it hits one of those X's just right, and it literally splits that laser in half. And what happens is you got one laser coming in, it splits into two different lasers. This one goes off that way, hits a sensor, and its spin is going that way. Okay? This one goes off the exact opposite direction, goes this way. So the whole laser goes in the same direction. That's very important, because a laser is when the lights go this way, okay, and it travels forward, and it's one photon after the other photon after the other photon after the other photon, the same ones that were drawn years ago, and it's a stream of polarized laser. That basically just means it creates a tube of light that gets very strong and incoherent. It doesn't like to get interrupted very easily, and they make them very tiny nowadays, and you do that. And you can do all kinds of crazy stuff, because what you actually have is a Y-shaped laser. As long as you don't turn off the laser at the beginning, you can test that one, and it's going to be whatever you want. You can test it for whatever, and it's going to change the other one. It's going to change the spin on the other one, because they're connected. It's one laser. Believe it or not, it's one laser. But it's a laser. So I can do the same thing here on Earth and shoot one laser up into space. I can get a right side spin on this one. So when I shoot it up into space, as it's going up, I got a left side one on this one and a right side on that one. So when it goes up and it hits a mirror on a space station, it comes back. When it hits the mirror, it reverses spin, just because of how mirrors work. It turns around, it comes back. So now I have a right side and a right side. And it's all one laser. It's not two particles on two different sides of the universe. Which brings me back to the double slit. The double slit experiment, where they're like, "Ooh, it's magic." It's not magic. It's everywhere at once. It's I don't even. That stuff. They broke science for the longest time. It's not everywhere at once. So what happens is you have a photon or a laser. It doesn't matter. They use lasers, and they just make them really small. And I got upset about this when I first started. They're lying about it. You know what I mean? I'm watching them use a laser, and they're like, "No, it's a single photon." I'm like, "You can't have a single photon with a laser." Anyway, point is that at the end of the day, it doesn't matter. Okay, so they shoot this laser at these two slits, and if you keep the laser on, you'll see what's going on. And the laser comes in and it diffracts, right? And you end up with this weird shape. And the weird shape doesn't make sense with the diffraction that you're using until you recognize what's going on. And what's going on is you have a pilot wave. So because it's going positive, negative, it's turning at the front of the laser. It's going positive, negative, positive, negative. It's creating or disturbing the electron field as it goes. And that creates a wave in front of it, of the electron field. And from there, the wave goes through both slits. Oi! The wave goes through both slits. The laser goes through one. It's not magically running around superposition everywhere at once and then just decides that that's the sensor it's going to take, and then it wave function collapses, and it's all stupidity, man. So what it is, the pilot wave goes through. The laser comes through. The pilot wave is still in front of the laser, and it's the electron field, and this thing is pushing through the electron field. And the thicker the electron field, the more dense the electron field. Believe it or not, we have density in electron fields. And check out gravity. All right. So as it's pushing through, it's creating a wave. And when it comes through, the waves, because now when it goes through the double slit, they interfere, and the laser comes in and rides the highest wave. It's called the pilot wave theory. And it don't matter if it's pushing a single photon or a stream of photons. As long as they're all in a laser, it hits like one photon. So you can have 40 seconds of laser, and it's still going to hit in the same spot. All right? And it's got nothing to do with the laser running around looking for a place to hit. It's just simply guided by that pilot wave. And it just guides it towards the back wall because it just came in. When it goes through the slit, that's when it decides. When it goes through the slit, it gets pushed in this direction or that direction to follow the biggest wave. Goes to the back, hits the wall. Hope I explained a few things. Y'all have a good day.